So, hello student. So, we are continuing the lecture on anaerobic digestion, and today in this lecture we will talk about pretreatment and co-digestion. See, in the previous lecture I shared about there are 4 stages, major stages on anaerobic digestion process, like starting from hydrolysis, acidogenesis and finally methogenesis. So, here in this one, and if you see that the major the stage is a hydrolysis process, that is the important one, and without this hydrolysis very difficult to go for acid phases or methane phases. Okay. So, here in this lecture we will talk about the hydrolysis process, which is rate limiting stage. If you do not have proper hydrolysis stage, it will take longer period for entire anaerobic digestion process, means the hydraulic residence period time or HRT will be very high if you do not have proper hydrolysis process. Normally this hydrolysis we can talk, we can also say that pretreatment. So, pretreatment is nothing but is a hydrolysis process, and along with that I am also going to talk about co-digestion process. Now, I think in the last lecture also I was talking about different substrate could be possible to use for anaerobic digestion process, but I did not talk about to have 2 substrates or 3 substrates together for digestion period, and what will the benefits of the biogas production by having the co-digestion process, that we will discuss today. So, first we will start with the pretreatment techniques. What are the benefits of the pretreatment, or especially the hydrolysis process, which is the rate limiting stage, and also talk about different ways we can have the hydrolysis process or pretreatment process could be possible before starting the acid phases and methane phases in the anaerobic digestion process. So, what is pretreatment? This is the improving the efficiency of microbial attack on the substrate. So, because see, I already shared in one of the lecture that for composting normally you will be required size of 1 centimeter to 2 centimeter, but for anaerobic digestion you will be required very small size of the substrate, could be 2 mm to 4 mm, likewise size if there. So, this anaerobic bacteria will be easily get degradation, they can start very easily the degradation process. So, this by this pretreatment, that is the initial process or for improving the efficiency of microbial degradation. And during the pretreatment process, the compact structure of biomass is easily exposed to the microbial attack. So, that is what, see, if the substrate is not properly pretreated, so it is very difficult for them and for the anaerobic bacteria to directly go for degradation process. So, after some particular time, I think they can start the degradation of such kind of waste also, but it will take more time, and especially for some of the organic material like lignin is very difficult to get degrade very easily. By this pretreatment process, this lignin kind of organic matter will be easily convert into the sugar, so that easily can be attacked by the microbes. So, this pretreatment process can be physical, can be chemical, can be biological, or otherwise we can combine the physical process followed by chemical process, or physical process followed by biological process. Likewise, we can make some combinations also. So, this pretreatment technology ensure the biomass disintegration and improve the solubilization in order to overcome the biological limitations of anaerobic digestion process. So, the idea is that if the entire organic material is solubilized very easily, solubilize one, so that it will be easily go for anaerobic digestion process. Though pretreatment of any substrate, not only biogas yield can be increased, but also higher calorific value of gas can be obtained, leading to less effort in the purification of biomethane production. See, this is another very important benefit of the pretreatment process. Not only it will increase the biogas yield, it will reduce the degradation period, means your HRT will be lower down by having the proper pretreatment process, and also the highly calorific value of the gas. What do you mean by the calorific value? Means more amount of methane could be possible. So, normally suppose if you do not have proper pretreatment process, your methane concentration will go maybe 55% or 60%, but having the proper pretreatment process could be possible to have more amount of methane, could be up to 70%. So, obviously, it will have more calorific value, and also it will have less effort to the purification of the biomethane production. So, obviously, if more amount of methane and less amount of carbon dioxide will be available. So, obviously, the effort for the purification also will be less if you have the proper pretreatment process. And this pretreatment are necessary when the readily biodegradable and soluble organic matter is unavailable, leading to the lower digestion rate. So, suppose I think the organic matter, if it is not easily biodegradable and if it is not soluble very easily or soluble organic matter, so obviously it will not be simply available for the microbial degradation in anaerobic digestion process. So, in that case you will be required pretreatment process. Also, rate of hydrolysis through the conventional anaerobic digestion is lower, result to the higher HRT of the digester and larger digester capacity or volume. See, this is also very important, the HRT, hydraulic retention period or hydraulic retention time is very important. Because of that only you will design the volume of the reactor, and if suppose HRT is high, so obviously you will be required the larger volume of the digester, and if HRT is lower down, obviously in the small reactor itself or small digester, small volume of the digester, you will be able to feed more amount of substrate as well as more amount of methane could be possible to produce from such kind of reactor. Or lower biogas yield, if suppose any organic matter is producing lower biogas, so by having or by including the pretreatment process or hydrolysis process, we can increase the biogas yield. Now, the effect of pretreatment on different type of substrate. So, there are various type of substrate for which biogas can be produced, and some of them are the lignocellulose substrate like crop biomass. So, there are different type of organic matter apart from MSW, organic MSW, possible to produce biogas out of different substrate, including lignocellulose substrate. What do you mean by this lignocellulose? Means the organic matter which is having more amount of lignin and cellulose or hemicellulose one. See, I think before starting that, just remember that if I am saying the organic matter, it will have 4 kind of different organic components. The first will be the sugar, which is very easily degradable from whether is a aerobic bacteria or anaerobic bacteria, if there is a sugar. After that, cellulose. Cellulose also could be possible by the bacteria, but not that very easily. Okay. So, you need to convert again that cellulose to the sugar for easily degradation from the bacteria. Now, third is the hemicellulose and last is the lignin. Now, both these hemicellulose and lignin is very difficult to get degraded by whether is a aerobic bacteria or anaerobic bacteria. Now, I think in composting process we already know that these kind of lignin or hemicellulose will be degraded by fungus, okay, by fungi, different in the maturation phase or the end of the thermophilic phase. But in the anaerobic digestion process, now is very difficult to degrade in a one single digester. Okay. So, these kind of waste which is having more amount of hemicellulose, more amount of cellulose or more amount of lignin is very difficult to produce the biogas, but it is a organic in nature. So, obviously could be possible, very is possible, but only you will be required very special kind of treatment process. So, that these lignin or cellulose or hemicellulose could be easily can be converted into the easily available organic phase like sugar for the microbial degradation. So, the first is the lignocellulose substrate like the crop biomasses like maize, wheat, and there are huge amount of crop biomass is producing, and you know that in Delhi when everyone is talking about air pollution by firing of agriculture substrate in Haryana and other nearby state of Delhi, they are talking about the firing of this kind of agriculture biomass. So, these agriculture biomass can be easily can be useful for production of biogas. Now, next is the crop residues. So, like rice straw, banana stem, this is also could be possible. This is what the huge amount of agriculture waste is producing in India or most of the developing countries. Now, next is the energy crops like sunflower crop, like oilseed crop. This is also, so once the product will come out from here, remaining will be the biomass. These biomass could be possible to use for the anaerobic digestion process, but the problem is that is high concentration of lignocellulose concentration. Various type of weeds like water hyacinth, hydrilla, salvinia, this is all aquatic weeds. This is also lignocellulose biomass, could be useful for the biogas production. These are some terrestrial weed or soil weeds like this is the well known one pathogens. Well known weed is available I think most of the states in India. And the organic waste such as food waste, this is what now, this is all MSW, okay, or organic MSW, municipal solid waste, where huge amount of food waste is getting produced or getting generated. So, this is also possible to produce biogas, possible to use for the biogas production. Now, what is the effect of pretreatment on lignocellulose substrate? You see here, now I put it here, this is the entire structure of organic matter. So, you see here the cellulose, hemicellulose and lignin. Lignin will be in the outside area will be the lignin, and these lines you are seeing, these are the hemicellulose, and this you are seeing this is cellulose. So, now when suppose any bacteria will target to degrade this one, now this lignin is not easily degradable. So, very difficult to reach to the cellulose also, if suppose cellulose also will get degrade. So, if you do the pretreatment, it will be now the cellulose, hemicellulose, lignin, everything is available for the microbial degradation. And now this is another way like liquid hydrolysis, by that also we can produce some solid residues which will be easily available for the microbial degradation. Now, this lignocellulose biomass have a diverse compositions and very complex structure which is resistant to the microbial degradation, and cellulose, hemicellulose and polysaccharides that can be hydrolysis to simple sugar. Okay. And lignin supports the cell structure, embedded cellulose and hemicellulose, hindering the susceptibility to microbial attack during hydrolysis process of anaerobic digestion. So, that is what I was talking about here. And pretreatment breaks the lignin layer and making the biomass to available to the microbes. and also the pretreatment also decrease the crystallinity of cellulose and increase the porosity. You see here, now this is the crystalline structure of cellulose. Now here attack from the bacteria is very difficult in this kind of structure, crystalline structure, but now because of pretreatment this entire crystalline structure will convert into non-crystalline structure. Now here is a separated, the organic part can be easily targeted by the for microbial degradation process. So, this is another benefit of the pretreatment process. And food waste can be easily degraded, but result in low biogas yield due to the presence of inhibitors and required pretreatment process. Now, especially the food waste, if you talk about this fruit waste or even vegetable waste, which we are normally disposing, which is not easily degradable or easily not eatable for the humans, which we are disposing of, that is consist of huge amount of hemicellulose or lignin. For that you will be required pretreatment to get available to the microbial degradation. Now, another substrate is a sludge biomass. So, there could be a different industrial sludges, can be a municipal wastewater treatment sludge, and there are huge amount of sludge is getting produced by aerobic wastewater treatment facilities or aerobic sewage treatment facilities. So, is a huge amount of sludge is getting generated. So, that also could be possible to use for the anaerobic digestion process. Also animal dungs, the different dung like cow dung and any cattle dung could be useful for the biogas production. And also the sludge from the various type of processing industries, different processing industries, but I think the sludge should be organic in nature, that is possible to utilize for the anaerobic digestion process. Now, what will happen with what is the effect of pretreatment of this sludge, these kind of sludge biomasses? Now, normally these sludge biomasses will have extracellular polymer substrate. So, like sludge biomass from wastewater treatment have high organic content, but is consist of numerous microbial cells, and wall of these cells act as a barrier against the enzyme degradation or microbial degradation. Also, this sludge will have extracellular polymer substrate like EPS, comprise a major organic fractions, and binding mechanism of EPS to the cation happening to be a significant factor determine the degradability of activated sludge. So, what is the benefit of that? By pretreatment process or hydrolysis process, see you here, this is the entire structure of the polymer substances. Now, after pretreatment process, the substrate will be easily available finally for the microbial degradation process. So, therefore, in this case hydrolysis step become rate limiting and degree of degradation limited, 30 to 35% COD reduction in conventional biogas anaerobic sludge treatment. Okay. Now, pretreatment of sludge rupture the cell wall of sludge flow structure and facilitated release of intracellulose matter into a aquatic phase, improving biodegradability with lower retention time and higher biogas yield. This is what we are looking for, improve the biodegradability and lower retention time or low HRT and high biomass yield. That is what the benefit of pretreatment of such kind of sludge biomasses. Now, another is a non-conventional biomass like crude glycerol could be one of the substrate for the anaerobic digestion process, which is producing from the different processes. Now, this is another one, the microalgae. This is also huge amount of productions. So, algae are capable of using sunlight and carbon dioxide and produce protein, carbohydrates and lipid through photosynthesis process. Microalgae biomass support higher photosynthesis efficiency, higher biomass yield and higher CO2 fixation than higher plant compared to the plant. Biogas production has been considered the simplest bioconversion process to obtain energy from the microalgae biomass. Now, normally this microalgae is used for carbon dioxide fixation process. So, this is a well known technique for fixation of carbon dioxide. Normally we use the microalgae, but once it is having the more amount of carbon dioxide, now has to be disposed of. So, rather than disposing into the landfill area, we can use and this is one of the simplest process for the getting benefit of the disposal of this kind of microalgae. Now, this microalgae also it will have this kind of structure. This is also not so easy for the microbial attack. So, by having the proper pretreatment process, you see here already has been cell wall is already ruptured by having the pretreatment process, which will be easily available for the microbial degradation process. So, the microbial cell envelope is made of thick and hard layer composed of complex protein and carbohydrates. This is what, and pretreatment improves the liquefaction process by biopolymer release enhancement and lead to solubilization of organic fraction, and pretreatment method increase the biogas yield and should be carried out at mild condition to prevent excessive sugar degradation. Okay. Now, there are different type of pretreatment process. Okay. So, we saw that the different kind of biomasses or different kind of substrate could be possible to use for biogas production, but all these kind of biomasses which in the last few slides I had shown that is having the more amount of hemicellulose, more amount of cellulose or more amount of lignin. So, it is very difficult to get attacked by the microbial degradation. So, if you have the proper pretreatment facility, can easily available for the microbial degradation and also could be possible to improve the biomass yield from the degradation process. So, now we will see the different types of pretreatment process. So, first is the mechanical pretreatment. It will reduce the particle size, break down the crystalline structure. So, it is a recommended 1 to 2 mm size for the effective hydrolysis of lignocellulose. Okay. I think this is what I think some can consider that you will be required energy again to produce the biogas. Increase the specific surface area by having the mechanical pretreatment. Mechanical pretreatment is nothing but a shredding you can say of or converting the entire material in smaller size like 1 to 2 mm size. Increase the enzyme degradation rate for hydrolysis. So, there are different mechanical pretreatment types could be possible by knife mill, by different shader, hammer mill or even ultrasonic pretreatment also is possible. So, now you see the by using the knife or hammer we can reduce the size, and this knife milling slices the fibers and typically produce small pieces, and also this hammer milling grind the fibers and typically produce the long thin fiber. Easily both these are easily available for the microbial degradation, and ultrasonic techniques can be used for pretreatment for the sludge or to treat the liquid effluent from anaerobic digestion process, and ultrasonic frequency like over 20 kilohertz cause cavities to form and can easily available for the those microbes for the degradation process. So, this is the industrial shader for mechanical pretreatment process. This is a simple cross flow shader. This is also mechanical pretreatment process. Now, next is the thermal pretreatment. So, substrate is heated around typically 125 to 190 degree centigrade and held at the temperature for a particular duration or particular time. So, by heating that particular substrate at higher temperature, that is the thermal pretreatment process. So, in the laboratory this can be carried out with the autoclave. So, this is also temperature in autoclave can go up to 120 to 150 degree centigrade. Hot air oven, so where temperature goes to 100 degree or 120 degree. Microwave oven, temperature can go 300 degree centigrade. Hot water bath. So, by these different techniques we can increase the temperature of particular substrate. And in lignocellulose substrate, the presence of heat and water disrupt the hydrogen bonds that holds together as crystalline cellulose and the lignocellulose complex causing the biomass to swell. So, once it will be swell by having the more temperature, higher temperature, it will be available for the microbial degradation process. So, this is a industrial scale thermal pretreatment, one of the industry. So, thermal pretreatment is only effective up to a certain temperature due to formation of inhibitory compounds at temperature beyond decreasing the biomass yield. So, now here important is that is not that if you have the more temperature will have more degradation and because of that more biogas yield, it is not like that. So, is a these temperature will be only beneficial for one particular temperature and beyond that temperature there could be a possibility of formation of inhibitory compounds and because of inhibitory compounds your biomass yield also will be reduced. So, temperature about 200 degree centigrade have been found responsible for the production of recalcitrant soluble organics or toxic or inhibitory compounds during the pretreatment process and for different biomasses different temperature will be required. So, I think initially we have to do some laboratory studies, one particular substrate will require how much temperature and how much duration. This is also important factor like some substrate will be required 30 minutes only, some substrate will be required 2 hours at this particular temperature and depend upon the temperature change like in the microwave oven the time requirement will be maybe only 5 minutes or in the 10 minutes itself could be possible to finish the pretreatment process. So, optimum condition that breaks down the substrate will be evaluated which varies from substrate to substrate. So, like 175 degree centigrade for waste activated sludge and for crop 190 degree centigrades. So, what is the disadvantage of this thermal pretreatment process? The energy requirement is huge. So, potential benefit should surpass the energy investment. So, this is one of the disadvantage because to get temperature up to 150 degree centigrade and there also you will be required a good amount of energy. Now, next is the chemical pretreatment. So, chemical pretreatment uses the range of different chemicals mainly acid and base of different strength under different condition. Some type of chemical pretreatments are alkali pretreatments. So, where we can use lime NaOH, calcium hydroxide. By addition of these chemicals, we can have the pretreatment process. Acid pretreatment. So, in acid treatment we can use acids, different acids we can use for the degradation process, and some oxidative pretreatments also could possible by adding hydrogen peroxide, even ozone. But what is the disadvantage of this process? Too much amount of oxygen into the system by addition of this, because oxygen is adding here. So, that is not that advantageous. Now, next is the biological pretreatment process. Biological pretreatment involves using microbial agents like bacteria, fungi, or even directly enzymes addition for the degradation process could be possible. So, the complex biopolymers such as protein, carbohydrates can be transferred into a simple end products due to action of various enzymes produced by the bacteria. Means it will increase the solubility of organic matter. And biological treatment with microbial agents lead to increase to around 30% biogas yield can be increased by having the some research. This is more beneficial. And biological pretreatment is applied by using direct microorganism as well as enzyme extracted from the microbes as catalyst to modify to degrade the complex biomass polymer. So, we can use direct microorganism, particular bacteria or fungus we can take and can add for the degradation process, or we can extract the enzyme from the microbes and these enzymes we can add for the degradation process. So, these are less energy intensive pretreatment with a high sensitive, no inhibitory byproducts and mild operation conditions. So, this is one of the very beneficial process, but the disadvantage the cost and complex for formulating the optimum biological agent mixture. So, this cost is only of microorganism cost and enzyme cost you will be required, and also because these all degradation will be of optimum operating condition, especially this pH and temperature, because the growth of these kind of bacteria, these kind of enzymes is depend upon the local conditions. So, these local conditions has to be attained for the degradation process, and if you do not have those optimum condition, maybe that added microbes or added enzyme won't work for the proper pretreatment process. Now, what are the types of biological pretreatments are? Could be anaerobic microbial pretreatment that utilize microbial fermentation under anaerobic condition, and could be aerobic microbial treatment process, could be both can be useful, because see hydrolysis process is a first phase of anaerobic digestion process. So, these could be aerobic also, is not only for anaerobic. So, it is possible that we will have two units, and the first unit the hydrolysis is possible, and second unit the anaerobic degradation will be there for biogas production. So, this hydrolysis process could be aerobic, and obviously, this aerobic microbial treatment is more beneficial than the anaerobic microbial treatment, because this aerobic bacteria is more faster, growth could be possible, and their degradation rate also will be far better than the anaerobic one. And also the fungal treatment also could be possible, like such as white rot fungi is a well known fungus. Like here also we can see in our kitchen, also we saw after 6 days, 7 days, if suppose that some food is getting degraded, we will see this kind of fungus. So, in this process this fungus will increase the solubilization, increase the biological yield. So, this was again the enzyme addition also is beneficial. I believe that rather than adding direct the microbes if you are adding the enzymes, that is more beneficial for the anaerobic digestion process. So, what are the disadvantage of this one again for especially for the enzyme addition, because it is a costly, because that extraction will be required, and in some substrate the enzyme dosage requirement is very high, making it uneconomical in spite of getting increase of methane yield. So, you will be required large amount of these enzymes for the degradation process. So, obviously, the cost will be more. Now, the pretreatment we finish. So, and if you ask me, sir, which will be the best method for the pretreatment process in the field. So, I believe that the chemical pretreatment I will not accept much, because the handling of those chemicals, like whether is a alkali or acids handling, that is why I did not talk much about the chemical pretreatment process. Now, for biological pretreatment process is possible to use, but only the requirement of the production of more amount of bacteria or enzymes or fungi. Now, if you are able to produce more also, you have to maintain also those, and will require the proper optimum conditions for that. And in the field, if you talk about that, the quantity requirement is more, and if you talk about the size of 200 tons per day capacity or 5000 tons per capacity biogas reactor, you will be required huge amount of microbes. That is also very difficult in the field one, but is possible in developed countries. There are many countries are utilizing the such kind of techniques, but in India or developing countries, I believe that the mechanical pretreatment is or physical pretreatment under the mechanical pretreatment is more beneficial, and there also the shading or grinding, if you do that itself is a highly beneficial for anaerobic digestion process. So, I believe that whenever you install any reactor, you have one grinder or shading process. So, and what should be the target of this grinding process? The target is to convert the entire material in the size of 2 mm or less than that, or 4 mm less than that. That should be the target. So, that this entire material, the size will be lower down and can easily go to the anaerobic digestion process. That is easy to work in the field, and even the large quantity of waste also can be handled by mechanical pretreatment process. Now, for co-digestion process, so what is anaerobic co-digestion? So, anaerobic co-digestion is a simultaneous anaerobic digestion of homogeneous mixture of 2 or more substrate to overcome the disadvantage of monodigestion and improve the economical viability of anaerobic digester. So, this is another idea about the hydrolysis process. See, now the one issue I talked about, this hydrolysis or pretreatment could be by different physical, chemical, biological process. This is another idea. If you add two different kind of substrate, so we can easily maintain the carbon to nitrogen ratio. Suppose the food waste which is lower in carbon to nitrogen ratio, and the agriculture waste which is having the more lignocellulose concentration also have more carbon to nitrogen ratio. So, by mixing up these two different substrate, we can optimize the carbon to nitrogen ratio. That is will be more beneficial for biogas production. So, and the monodigestion, especially the monodigestion or especially these lignocellulose biomass alone for biogas production is required very proper pretreatment process, and if you do not want to use for pretreatment process, go for co-digestion process by addition of different easily degradable organic matter. So, use of co-substrate improves the biogas production in methane yield due to establishment of positive synergism in the digestion medium and optimum attainment of lacking nutrients from the co-substrate. So, substrate having high carbon to nitrogen ratio, monodigestion has poor process stability. So, the substrate is having high carbon to nitrogen ratio, having the monodigestion with a poor process stability, and addition of nitrogen rich co-substrate is optimum ratio enhance biomass degradation. So, co-digestion of different feedstock with animal manure can increase biogas production from 20 to 400% compared to the monodigestion of same substrate. So, especially here talked about animal manure. Suppose that is why I think in India when anyone is running the biogas reactor, they are talking always talking about addition of some cattle manure, especially cow dung, because cow dung is a high nitrogen rich organic matter easily, and also having the huge amount of microbial consortia. So, if you add such kind of animal manure or animal waste or could be used for the biogas product, co-digestion of the lignocellulose material. So, what is the advantage and disadvantage? So, the advantages or benefits of anaerobic co-digestion process, like dilution of toxic substance, nutrient balance, that is the carbon to nitrogen ratio, and also synergetic effect of microorganism. So, these are the benefits from addition of other nitrogen rich material. So, what are the drawbacks? Drawbacks could be increased digester efficient COD. So, because when you are adding even cow dung also into the reactor or any other nitrogen rich organic matter, is not only your nitrogen you are adding, but also the carbon you are adding into the particular material, particular mass. So, obviously, your total chemical oxygen demand will also increase, and also the increased mixing requirement, because both has to be mixed properly. So, there also you will be required energy. Now, I think we saw this is the one particular flow of biogas production. So, I was starting from pretreatment, acidogenesis, methogenesis. So, by adding of another organic matter, disintegration could be possible, and also parallelly the hydrolysis, acidogenesis, this method will follow, and obviously it will be beneficial for increase of more biogas. Now, what are the factors affecting anaerobic digestion process? Like first is the chemical composition of the substrate. So, the characterization of chemical composition of different substrates is helpful to identify the appropriate substrate, and classifying the substrate according to their biochemical compositions can be useful to evaluate the biodegradability and bioavailability of the substrate. And there are different factors. So, different factors could be bioavailability, temperature, pH, moisture. So, the first is the carbohydrate rich organic material. So, like carbohydrates are present in all substrate in different proportion, like food waste is enriched with complex sugar and disaccharides, easily decomposed with the formation of volatile fatty acids. So, what could be the problem of addition of these kind of organic matter for co-digestion process? Like higher level of simple sugar result in rapid volatile fatty acids accumulation. So, because of that it will decrease the pH, and because of that your methane production will be reduced. So, what is the solution? That for balance operation of anaerobic reactor, mixing the feedstock containing high amount of simple carbohydrates with waste with a lower content of easily degradable organic components is recommended. So, here what is the idea? To balance both. So, by adding the high amount of simple carbohydrates with waste with a lower content of easily degradable organic compounds. If you mix both kind of material, you will not find the problem of rapid VFA accumulation. Now, next is the protein rich organic material. What could be the problem? During digestion, protein converts to amino acids which have an amino group, and could possible to produce ammonia, which will inhibit the microbial degradation process. Okay, that will be also major problem. So, what is the solution of that? Suitable co-substrate with adjustment of carbon to nitrogen ratio you maintain should be optimum to minimize this kind of problem. So, another addition by fat rich organic materials. So, there could be also possible high concentration of fats, lipid causes blocking, adsorption of biomasses, and microbial inhibition could be possible. So, for that solution also the mixing carbohydrate rich material with a fat rich material, slowly degradable and fast degradable, are advantageous in nutrient balance. So, see here, carbohydrate rich material with a fat rich material means slowly degradable to the fast degradable are advantageous in nutrient balance, that will improve the methane yield in the biogas reactor. Now, the next factor is a temperature. So, microorganisms grow best at temperature ranges of mesophilic and thermophilic, and co-digestion process with a high concentration of ammonia is unstable in the thermophilic temperature range. Now, next factor for temperature. So, this biogas reactor could be possible to run at mesophilic temperature also, at thermophilic temperature also, which we talked in the previous lecture. So, here is only the problem in the co-digestion process with a high concentration of, because at thermophilic temperature there could be possibilities of higher concentration of ammonia, and you know that this ammonia is inhibitory for methane yield. Next is the pH. So, the optimum pH for is a 6.8 to 7.2 for co-digestion process. So, the co-digestion can enable a stable pH value by avoiding the extreme acidification condition. The change in pH of mixed raw material in co-digestion is more stable, easier to maintain the optimum pH range for degradation process. Next is the carbon to nitrogen ratio. This is important for degradation process. So, mixing of carbon rich substrate with nitrogen rich substrate like animal manure and kitchen waste. So, that will be more beneficial to maintain the proper carbon to nitrogen ratio, and normally the optimum range of carbon to nitrogen ratio is 20 to 30 is good for the methane production. And if carbon to nitrogen ratio is high, there could be a possibility of producing large amount of volatile fatty acids, which is the inhibitory for biogas production. And if CN ratio is low, there could be possible of more ammonia production. So, that is also inhibitory for the biogas production. Now, if you see that there are different substrate are having the different carbon to nitrogen ratio, like you see here kitchen waste is 25 to 29, and suppose you take here sawdust or even other kind of agriculture residue will have more carbon to nitrogen ratio. If you mix, like here you take food waste 3 to 17, so this is not optimum. So, by mixing these to these at particular concentration could attain proper carbon to nitrogen ratio. So, by CN ratio, high CN ratio and lower CN ratio, if you mix into a same reactor at proper concentration, we can get proper the biogas production also, and good quality of digested also could be possible. So, now in this lecture I talked about there are two ways we can have the hydrolysis process, one for the pretreatment process and other from the co-digestion process. Now, if you compare the both techniques, is again depend upon the local conditions. So, suppose in the local conditions you are finding there are large variety of organic matters are available. So, obviously, I believe that the co-digestion will be more beneficial, and some of the locations where only one particular kind of waste is available, and for that you are going for anaerobic digestion process. So, in that case plan for some mechanical pre-treatment process. So, based on the local conditions, local waste availability, we can go for either monodigestion with the mechanical pre-treatment process, or co-digestion with available different organic matters in the local area. Also, we can mix both by having the different substrate mix, and we can go for mechanical pre-treatment process, that is also more beneficial. So, the target is that your HRT should be lower down, that is first point. Second point, there should not be production of inhibitory compounds like VFA or ammonia, and these are the important and the maximum methane production. These are the three major factors you consider, and go for either pre-treatment process or co-digestion process. So, thank you for today.